All right, let's move on to 2-4. See what we can do on it, get done on it before we leave today. Okay, so now we've analyzed, we've looked at analytically figuring limits. Okay, now we're going to look at infinite limits. Okay, so one thing to remember on this, okay, the only way for a limit to exist is when it approaches a single value from both sides. Okay, so we're not saying here with an infinite limit that the limit exists. Okay, we're just describing the behavior. Okay, so the only way for a limit to exist is when it approaches the same thing from both sides. All right, but we can say if that limit, so as x gets bigger and bigger and bigger, then the y value grows without bound, or the y value decreases without bound. So that's what we're doing here. Rather than just saying it does not exist, if we can describe what's going on with the end of the thing, then we describe it. Okay? So suppose f is defined for all x near a. If f of x grows arbitrarily large for all x sufficiently close but not equal to a, we write that. So if it's growing as x approaches a, you put infinity symbol. Right? If it is decreasing, negative infinity. Okay? All right, so say one more thing here. We write that. And say the limit of x as x approaches a is negative infinity. In both cases, the limit does not exist, though. Okay, he does say that. Okay, good. So the limit does not exist, but we're just describing what's happening. All right, so here's visually what's going on. Okay, so as x approaches a, from the left, it's going up, up, up. From the right, it's going up. So we would say, since it's doing the same thing from both sides, that limit would be approaching infinity. Okay? Here, as you approach a, it's going this way, so the y values are going down, 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 negative infinity. Okay? Here, well, same thing. All right, you just got them. All right, questions? Okay. All right. All right, one-sided limit. Suppose f is defined for all x near a with x greater than a. If f of x becomes arbitrarily large for all x sufficiently close to a with x greater than a, then we write that. All right, so same thing with one-sided. All right. So if I'm just looking at it from the left, we could say that that approaches infinity. If it's this one and I'm approaching from the left, that one would be approaching negative infinity. Okay? And then the same thing with these two here. Questions about that? Okay. That leads to a definition of a vertical asymptote, which you've talked about those before with functions, right? The inverse trig functions, all right, or the trig functions, tangent, cotangent, cosecant, secant, they have vertical asymptotes. Rational functions have vertical asymptotes. Okay, so they appear. But if the limit as x approaches a of f of x is equal to plus or minus, so either positive infinity or negative infinity, then that is a vertical asymptote. Okay. Any questions about that or anything? All right, look at some problems here. All right, first one we just got a graph, so we'll do this one up here on the board. See if I can write it over here. All right, so on the A part, the limit as x approaches negative 2 from the left. All right, what do I put from the left? Negative infinity. So negative infinity. B, negative 2 from the right, what would that be? Negative infinity. So, what is the limit as x approaches negative 2? Both sides doing the same thing? So I would say it approaches negative infinity. Okay? Now notice the difference with D, E, and F. All right, with D, as it approaches 3 from the left, what's it doing? Positive infinity. As it approaches 3 from the right, it's approaching what? Negative. What would I need to say about the function as x approaches 3? Does not exist because it is not doing the same thing on both sides. Okay? Questions about that? All right, got a bunch of problems here to do. All right, let's go back over here. See what we got. Okay. Now, we just did those with the graph, okay? And that's fine and dandy, but we want to do these without a graph, okay? We want to do it more by thinking about what's going on, okay? So first let's think about this without thinking about the graph, okay? So really, you know that you're going to have a vertical asymptote at 2 because this rational function will not reduce. So you're definitely going to have a vertical asymptote at 2. So the question is it going up or is it going down on either side? What's it doing? Okay. So you really just need to think about the sign. Okay. So for this one, for all of these, notice the top is positive 1. So I'm just going to go ahead and put positive on the top of all those. Okay. Actually, this one, let's don't do this one yet. Okay, just those two from each side. Okay. Now notice as this bottom approaches 2 from the right, would this bottom be positive or negative as it approaches 2 from the right? Positive. If you think about 3, 3 minus 2 is positive. All right. So this would be approaching what then? Positive over positive, positive infinity. Okay? Here, as you're approaching 2 from the left, what would the sign of the bottom be? Negative. Positive divided by a negative would be a what? Negative. Negative infinity. So you've got one side approaching positive infinity, one side approaching negative infinity. So what would I say about the limit as it approaches 2? Does not exist. Okay? Now we can graph this. If you remember all your 21 graphs to know, you can graph this without having to do anything, right? Because y equals 1 over x, what does that one look like? This and this, right? If I subtract 2 from x, how does that shift the graph? Minus 2, how does that shift it? Right, 2 units. So I would have 2. I got that, right? So we said from the left. I got that backwards. I'm sorry. I say that I'm saying this way, right? It's just rigid, all right? So from the left, what's it doing? The y is going to negative infinity. From the right, positive infinity. That's what we said, okay? So you can think about it graphically, or you can think about it like that with the signs, okay? All right, so notice on these, if we do it with the signs first, okay? Notice the bottom is squared. What's true when you square something? What sign is it? Positive. So on both of these, the bottom is always going to be a positive no matter what you plug in, okay? Now on the top, as I approach, if I can just plug 4 into the top. What's 4 minus 5? Positive or negative? Negative. 4 minus 5. Both of those, I get a negative over a positive. So that should be approaching negative infinity for both of them. Okay? So what would the limit as x approaches 4 be? Negative infinity. Okay? Let's graph this one on Desmos real quick over here. Okay? So as we approach 4 from both sides, the y's are going down, negative infinity. Okay? All right, questions about that? All right, so we're looking at that function as it approaches negative 2 from the left, from the right, and then just negative 2. All right, so this will not reduce. So you actually would have two vertical asymptotes on this one. You have one at 0 and one at negative 2. Okay, so let's see what's happening. All right, so x minus 4, I can just plug negative 2 into that. What is negative 2 minus 4? Positive or negative? Negative. All right. For x, I can just plug negative 2 in. Negative. All right. As x plus 2 approaches negative 2 from the right, is that going to be positive or negative? Positive. So I've got a negative, and a positive, multiplying and dividing. What does that give me? A positive or a negative? Positive. So that should just be approaching infinity. Okay. This one, again, x minus 4 is negative. X is negative. X plus 2, what is that approaching as you're coming from the left? Positive or negative? Negative. So I've got 3 negatives. What does that give me? A negative. Approaches negative infinity. So what does that mean about the limit as it approaches just negative 2? Does not exist. Okay, very good. All right, questions about that? Now, the last 2 or 3 that we did, I started out by saying that will not reduce, all right? If the rational expression will reduce it, okay? Because before you can say it's a vertical asymptote, you got to know that it is reduced, okay? What can I do to the top there? What is the top? Difference of 2 squares. So I would factor that and see what happens. So I'll have the limit as t approaches 5. So that will be 2t plus 10. 2t minus 10. I tell you what, let's take a 4 out first. So if I factor a 4 out, that'll be t squared minus 25. So I will get 4 times t plus 5 minus t minus 5 over t minus 5. Okay. Now, I can divide out that t minus 5. So I get the limit as t approaches 5 of 4 times t plus 5. And now I can plug 5 in. That would just be 40. Okay. So always, if it will reduce, you got to do that. Okay. The only time you can say I have a vertical asymptote is after you have reduced the rational expression. Okay. Questions? 2 problems here. All right. So the first one, limit is x approaches 1 from the right of that. Okay. So I would look at that x squared minus 5x plus 6, and I would think, well, that I could factor. Okay. And it will. But I will get x minus 3, x minus 2 over x minus 1. So it will factor, but it will not reduce. Okay? So 1 really is a vertical asymptote. Okay? So I want to know what's it doing as x approaches 1 from the right. Okay, well, let's just look at the signs, okay? So the top, I can plug 1 in. 1 minus 3, that's always approaching negative. 1 minus 2, that's always approaching a negative. All right, what about on the bottom? As I approach 1 from the right, what sign is that going to be? Positive. So I got a negative times a negative divided by a positive is going to give me a what? Positive. 2 negatives, right? So that would be just infinity. Okay, should be going up from the left, from the right. Okay. All right, this one, same kind of thing. All right, so that will not reduce. Okay. 6 definitely is going to be a vertical asymptote. All right, so from the right, if I plug 6 in the top, I get a negative. What's the sign always of a square root? that the way we define it. We always define it as positive, right? Now, you couldn't come from the left, correct? If you came from the left, you would have a complex number. So you'd only come from the right. Positive, negative divided by a positive is a negative, so it's negative infinity. Okay? Questions about that? All right, let's do one trig one. Okay, and then we've got 3 more of those next time. Then we'll get to 5 real quick next week or on Wednesday. All right, let's say that we've got the limit as theta approaches 0 from the right of cosecant theta. Okay? Now, what do you have to know about cosecant here? You got to know the graph, okay? So why are we having our quizzes every day? So we can remember the graphs, right? Because you got to know what they look like. So all I would do here is just think, all right, well, cosecant is reciprocal of what? Sine or cosine? Reciprocal of sine. So if I draw the sine graph here, like this, then my vertical asymptotes are always going to be where I have my x-intercepts, which for cosecant and cotangent, that's at 0 and pi, all right? And then my graph goes like this, like this, like this. Okay, so looking at the graph, as it approaches 0 from the right, what is it doing? Positive infinity. Okay. Any of those, I would do that. I would think about the graph on those. Now you could plug in some values, but all right, here we go. So we're going to just finish up 2.4 and then go to 2.5 today, and that should be all we do today. What was the last one we did? Was it the cosecant of theta? Limit is theta approaches. Okay. All right, so really just have 4 more of these on here to look at. Now, the one before this one was the limit as theta approaches 0 from the right. This same thing, cosecant, except with x, approaches it from the left. Okay, so the main thing with these trig functions, cosecant, cotangent, tangent, is to just remember that they have vertical asymptotes wherever they're undefined. And probably what's going to happen is it's going to say, what's it doing as x approaches that asymptote? So if you can remember what the graph looks like, then, that's the way I would do those. Okay, so like if I have the limit as x approaches 0, this time from the left or right? Let's see. From the left of cosecant x. So again, think about the graph. Okay, so what I would want to think of is, well, cosecant is the reciprocal of sine. So if I draw the sine graph, which looks like this, all right, and like this, then the vertical asymptotes are wherever the x-intercepts are. So that's going to be at 0. It is going to be at pi. And then it will also be at negative pi. Negative 2 pi, positive 2 pi, so on and so forth. All right. Now the way that the graphs work, wherever the maximum and minimums are of that sine function, that's where your cosecant graph will come off of. So this will look like this. This will look like this. Okay. So the limit as x approaches 0 from the left. So as x is approaching 0, what are the y values doing on this one? Down, down, down. Right? Negative infinity. Okay. So any questions about that one? We have the cotangent function, and we're multiplying by negative 10. Right? Well, how does negative 10 affect that graph of cotangent x? So the normal graph looks like this. Your asymptotes for cotangent are at 0, pi, 2 pi. All right, need to remember that. So this would be, have one there. I would have one here at pi, 2 pi. All right, we're looking at 0 from the right, so that's all I need. All right, so normally cotangent would go which way? Does the left side go up, or does the right side go up on cotangent? Left goes up, so it would look like this. Okay, that's what the normal graph looks like, all right? What does the negative 10, how will that affect that graph? What will the negative do to it? Guess what? It's going to flip it across the x-axis. Reflects it across the x-axis. What about the 10? It's just going to stretch it, okay? It's not going to affect the period of the graph, okay? So remember with the trig, the period will be affected by whatever you multiply times x, right? So it's not going to change your asymptotes or any of that. It's not going to move it up or down or left or right. It's just going to stretch it some. So it's still the same shape, except the negative will make it go like this. So it will go, okay. So the limit as x approaches 0 from the right, what's it doing? Positive or negative infinity? Negative infinity. Okay. Questions about that? All right, the limit as theta approaches pi over 2 from the right. Okay. 1/3 tangent theta. Now, again, the 1/3 is, all it's going to do is stretch that graph a bit or shrink it. It's not going to change, it's not shifting it anyway, and it's not going to change the period. To do that, you'd have to multiply theta by something. Okay, so for the tangent graph, where are your vertical asymptotes for tangent? Tangent is y over x. Where on the unit, so when x is 0 on the unit circle, that is where tangent is undefined, that's where your vertical asymptotes would be. So on your unit circle, right there, that point is 0, 1, this point is 0, negative 1. So tangent's y over x, so at this one right here is where you would have an asymptote. What is this angle here? 90 degrees, pi over 2, okay? Or negative pi over 2, or 3 pi over 2, or negative 3 pi over 2, you know, so that's where your asymptotes will be. It would be helpful if you just remember, if the function starts with c, cosecant and cotangent, the vertical asymptotes are at 0 and pi. If it is not c, tangent or secant, like tangent and secant, the vertical asymptotes are at pi over 2, 3 pi over 2, negative pi over 2, those. Okay? So I would just know, all right, that is a vertical asymptote. Pi over 2, negative pi over 2. There are my vertical asymptotes. The 1/3 is not, it's not negative, so it's not going to flip it. So I remember the tangent function falls to the left and rises to the right, like that. So as x approaches pi over 2, so I'm going to have to draw another one, aren't I? So 3 pi over 2. All right, so what is it doing as it approaches pi over 2 from the right? Positive or negative infinity? Negative infinity. All right. So any questions about those? Okay. Now, is positive infinity and negative infinity the same thing? No. It's either one or the other. Okay. So if you got the wrong sign, you got it wrong. So you know you gotta know which direction it's going. So. All right, let's see. One more, and then we'll move on to the next section. Now, sine and cosine, they do not have vertical asymptotes. All right, now if I can't reduce this, we would with the denominator there, all right? But can I reduce that? Well, you got cosine squared in the denominator. What do you think of when you think of cosine squared? Y'all need a break, don't you? So it's almost, you almost got a holiday coming up. What do you think of if you see cosine squared or sine squared with trig? Nothing? The what now? Okay, how could you do that? You can, yes. One of the formulas, Pythagorean Identity, remember those? All right, sine squared theta plus cosine squared theta equals 1, right? Remember that? So, if you ever see cosine squared, sine squared, tangent squared, any of those squared, you could use that to be helpful. So notice here, if I subtract 1 here and subtract sine squared, I get cosine squared theta minus 1 equals negative sine squared theta. Okay, so cosine squared minus 1 is the same thing as negative sine squared. So let's put that in the place of this. I get sine theta over sine squared theta, negative sine squared theta. All right. So that will give me, I can cancel with a sine out with one of them on the bottom. Limit as theta approaches 0 from the left of negative 1 over sine theta. Okay. Now that one we cannot reduce anymore. Okay. So I would do just what we did before. It definitely will have an asymptote at 0, because if you plug 0 in, what is the sine of 0? The y value here is what? 0. All right, here's 0. The y value right here is 0, so the sine of theta is 0. All right, so I have 1 over 0. That's got to be an asymptote. Okay, so notice the top is always negative. As you approach sine or 0 from the left, okay, what sign will sine theta be? Okay, so think of what you're looking at. You're looking at angles, right? So 0 is right here, okay? So as I approach 0, I'm come from the, which way did I say? Left? Okay, so that would mean from smaller ones, right? Okay, where are smaller angles? Is it clockwise or counterclockwise? As I go this way, the angles are getting bigger, which is different than it is on an XY axis. If you go this way on the XY axis, your number's getting smaller, right? So if I'm coming from the left, I'm coming from this way, right? What is true about your x's throughout here? Are they positive or negative?
Positive.
They are positive. The y's are negative, but the x's are positive. So I said x's, didn't I? All right, we're talking about sine. Okay, so what is true about sine there? The y's are negative on the unit circle as you go towards 0, which makes the bottom 0, or bottom negative. And negative divided by negative is what? Positive. So that is positive infinity is what the thing approaches. Okay, those were infinite limits. Okay, so which are really vertical asymptotes, right? So as you approach some x, it's going to grow without bound or go down without bound. Okay, so the next thing we'll look at are limits at infinity.